Alright, so in this problem, I have 45 to the power of x is equal to 90. So to solve this, I'm going to first start by taking the log on both sides. So now I have log 45 to the power of x is equal to log 90. Now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is the same thing as b times log a. So in this case, I have log 45 to the power of x, and I can move x to the front. So now this is the same thing as x times log 45, which is equal to log 90. Now, if I divide both sides by log 45, these two cancel out, and now I have x is equal to log 90 over log 45. Log 90, that's the same thing as log 2 times 45. So I have this over log 45. And if I have something in the form log a times b, this is the same thing as log a plus log b. So now I have x is equal to log 2 plus log 45. Now I have this over log 45. So now this is equal to log 2 over log 45 plus log 45 over log 45. And now log 45 and log 45, these two cancel out. So now I have x is equal to log 2 over log 45 plus 1. And if I have something in the form log a over log b, I can write this as log base b of a. So log 2 over log 45, that's the same thing as log base 45 of 2, and I have this plus 1. Alright, so in this problem, I have 3 to the power of x plus 9 to the power of x is equal to 27 to the power of x. So to solve this, I'm going to first start by rewriting 9 to the power of x as 3 squared to the power of x, and 27 to the power of x as 3 to the power of 3 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So I can rewrite these as 3 to the power of x plus 3 to the power of x to the power of 2 is equal to 3 to the power of x to the power of 3. Now I'm going to let 3 to the power of x equal to y. So now I have y plus y squared is equal to y to the power of 3. And this cannot be written as y to the power of 3 minus y squared minus y is equal to 0. Now if I factor out y, I get y times y squared minus y minus 1 is equal to 0. So this gives me two equations. I get y equals 0 and y squared minus y minus 1 is equal to 0. So for y squared minus y minus 1 equals 0, I'm going to use the quadratic formula. And if you do end up doing it, you should get y is equal to 1 plus or minus the square root of 5 over 2. So my solutions for y are 0, 1 plus the square root of 5 over 2, and 1 minus the square root of 5 over 2. Now remember how we set 3 to the power of x equal to y. So I have 3 to the power of x is equal to 0. This is our first value of y, and you can't take the power of a number and make it equal 0, so this is wrong. Now I have 3 to the power of x is equal to 1 minus the square root of 5 over 2, and you can't, 1 minus the square root of 5, that's going to be a negative number, and you can't take the power of a positive number and make it a negative number, so this is wrong as well. So I'm left with 3 to the power of x is equal to 1 plus the square root of 5 over 2. So to solve this, I'm going to take the log on both sides, so I have log 3 to the power of x is equal to log 1 plus the square root of 5 over 2. Now I can move this to the front, so now I have x times log 3 is equal to log 1 plus the square root of 5 over 2. And if I divide both sides by log 3, I get x is equal to log 1 plus the square root of 5 over 2 over log 3. Alright, so in this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 9 to the power of x. So I'm going to first start by factoring out 3 to the power of x. So I have 3 to the power of x times 1 plus 1 plus 1 is equal to 9 to the power of x. Now, if I simplify this in the parentheses, I get 3 to the power of x times 3 is equal to 9 to the power of x. Now, 9 here is the same thing as 3 squared. So now I have 3 to the power of x times 3 is equal to 3 squared to the power of x. And if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And m and n, well, I can change the place of these two. So this is the same thing as a to the power of n times m. So if a to the power of m to the power of n is equal to a to the power of m times n, then a to the power of n times m, that should equal a to the power of n to the power of m. So 3 to the power of 2 to the power of x, I can switch the places of 2 and x. So now that's the same thing as 3 to the power of x times 3 is equal to 3 to the power of x to the power of 2. Now I'm going to let 3 to the power of x equal to the variable t. So now I have 3t is equal to t squared. Now if I subtract 3t on both sides, I get t squared minus 3t is equal to 0. Now if I factor out t, I get t times t minus 3 is equal to 0. So I have two equations now. I have t equals 0, and I have t minus 3 is equal to 0. T equals 0 is already a solution for t. T minus 3 equals 0, meaning t is equal to 3. So now remember how we set 3 to the power of x equal to t. So I have two equations. 3 to the power of x is equal to 0, and 3 to the power of x is equal to 3. So for 3 to the power of x equals 0, well, you can't take the power of a number and make it equal to 0. Nothing to the power of anything is equal to 0. Now 3 to the power of x equals 3, well, 3 to the power of 1 equals 3. So x is equal to 1, and this is my answer. Alright, so in this video, I'm going to be solving the equation 6 to the power of x is equal to 60. So to solve this, what I'm first going to do is I'm going to be taking the log on both sides. So I get log of 6 to the power of x is equal to log 60. Now, if I have something in the form log of a to the power of b, I can move this exponent b to the front. This can equal b times log a. In this case, I have log 6 to the power of x, and I can move x to the front. So I get x times log 6 is equal to log 60. Now from here, I'm going to divide both sides by log 6. So then these two cancel out, and I get x is equal to log 60 over log 6. So now from here, what I'm going to do is I'm going to rewrite log 60 as log of 6 times 10. And if I have something in the form log of a times b, this is equal to log a plus log b. So log 6 times 10 is going to equal log 6 plus log 10. And I evolve this over log 6. Now, from here, if I have something in the form a plus b over c, this is equal to a over c plus b over c. So log 6 plus log 10 over log 6, I can write this as log 6 over log 6 plus log 10 over log 6. Now, log 6 and log 6 cancel out, so I get x is equal to 1 plus log 10 is also equal to 1. So I have this over log 6. And if you guys already didn't know, log 6 is equal to log 3 times 2, which is equal to log 3 plus log 2, which is equal to 0.7781. So if I plug this in for log 6, I am left with x equals 2.2852.